The mathematical symbol of today is the sum symbol, written as a capital sigma. And below the sigma, usually you find a name for an index, so for example, it could be k. And if you see k is equal to 1, this means 1 is the starting value for the variable k. On the other hand, on the top of sigma, you find the end value for the variable k. This means if this is the sum of the numbers ak, then we get a1 plus a2 plus a3 plus and so on until we reach an. This means that we start with the index given here, then we increase it by 1, do the addition, then we increase it by 1 again, do the addition again, until we reach the value for the index given here. So this whole thing here should explain what the sum symbol means. However, in a formal way, you can also write down a recursive definition for the symbol. More concretely, this means first I tell you what happens when n here is equal to 0. Then the whole thing from above wouldn't make any sense, because by just increasing the index by 1, we would never reach 0 here. However, in this case we define it as the empty sum, which means it should be 0. In other words, if we don't sum anything, we stay at the value 0. And then in the second step for recursive definition, we need to know what happens to the successor. Or more precisely, the successor n is defined by the predecessor n-1. Indeed, this is not hard to understand. If we have this sum from k is equal to 1 to n-1, we just have to add the last term to get this sum. And then you see, this is our recursive definition for the sum symbol. And with this, you shouldn't have any problems generalizing this to other starting indices here. Okay, so I hope I see you in the next video. Bye!